Hello and welcome back, PlayBASIC Coders. A question came in about controlling the compiler from the command line the other day. So let's have a look at that. There's a tutorial here that's all about actually how to control the compiler, not the IDE, the compiler. So this is how the IDE and the compiler talk to each other. The compiler is just a command line program pretty much, and that if you were using the CLI, the command line stuff, not the graphical interface from your operating system, if you navigate to the folder of PlayBASIC and you could just say, playbasic.exe, and then it would run the compiler. Those things have control codes after the file name. So that's pretty much every bit of software has the same thing. So the way the IDE and compiler talk to each other is that the IDE calls the compiler and then passes the compiler the location of the project file. And this is a compiler project file, not an IDE project file. They're different things. Across. So where are we? Well, this whole document here actually goes through everything, really. Pretty much everything you need to see. Some of it we can't see because we're not logged into the site, but most of the information that's here straight out of the box. This is a compiler file, a compiler project file, just a text file. The extension of the file doesn't matter. It could be called anything, myproject.anything. It doesn't matter. And inside that file is just a bunch of text that has these blocks, HTML sort of style, really, where we have a section, it's the general section here. And inside that we have a bunch of these parameters that you would otherwise need to pass to the compiler directly every time you call the compiler. So imagine having to, to run your program, having to go playbasic.exe and then giving it the name of the source, your author names, your default screen widths, it was just not practical. So that's why it does this stuff in the first place. And there's other elements here too. I think there's even more blocks than this. These are debugger watches. They're irrelevant for people. Linker, same thing really. So what you could do is you could just grab this as text and then save that out, and that would be a valid project file. Now because it's not pointing to a source file that the compiler would be able to find, it would not work. Makes sense, right? Here it's got more of an elaborate thing about what these things are representing, and if you look at this file, these settings, you can pretty much track them back to what the IDE does anyway. So you've got like a debug mode setting, the author of the project, the splash screens, all that kind of good stuff. That's all there for you. This is all still valid for 165, by the way, even though this was written, 2008. There are more command line instructions for 165, but they're irrelevant for this context. They're for other uses, right? To have the compiler do other things than just load a source, compile it, and run it. All right. So what was the question? Sorry, it's a bit of backtracking. So look at that. How can I compile the follow the instructions? Now I tested this before, and I know why this is not going to work the way you're doing it here, and I'll show you why. So the shortcut files are just an OS way of saying this is clicking this file here is an alias for some other program. Inside that shortcut, there's a target variable and some properties and a few other things too, I forget now. And as I was saying before, the compiler, the name of the compiler, the playbasic.exe, it expects the absolute location of the file after that. So you have to edit that that shortcut to include the full path of the project file you want it to run and load, compile, and run. We'll flip across here. I've got one of these already opened up. Where are we? CLI test. Yeah, this is the project. So when I go to this, I can't run these for obvious reasons because the shortcut location doesn't exist on my computer. Right, that's not going to work. But if you hit properties, so there's target location here. How we're targeting this particular file, it's the executable file here. What we need to do is add the location of the file we want to build inside here. Since that's not where mine is, I'll just go make another one. Cancel, thanks. So, PlayBASIC Classic. This is where the builder or the current in development version sits. There's a shortcut there. We'll just delete that for a second. In here, create shortcut. And then drag the shortcut across. Or you can cut and paste it if you wanted to, I guess. Would make no difference. Now, in here we have different versions of the same project. These are IDE projects. They're not compiler projects. Compiler does not understand what that is. So I drag this over here. You'll see it's a text file, but it's an XML formatted text file. And the reason for this is it's long and evolved. The IDE that you know, or people know, is the current IDE, was not the original one. So there was a project format of really old projects that is in the one that we call a compiler project these days, that it used to use. When Empty built Playwright, he decided to use XML, which creates this this parallel situation where you've got different bunches of data going on. So in this structure here, we have things that a compiler doesn't really need. I'm assuming these are traces and watches would be line numbers of what files things are in and that kind of stuff. I don't remember now. The actual source is just straight text. There's nothing special about source. Right. Now, this temp file over here, temp.project, and it's just called that so we can have a difference between what the IDE does. It actually generates this temp file. As we were saying before, it looks pretty much as we expect it. We've got these blocks, a general block, watches, linker. Each section relates to those properties within that thing that we're referring to. We could pretty much have some of these broken up yet again, like, there could be like a splash section or whatever. There's no point doing it now. But they're just plain text. In here, it's got the temp.source. Now, of this file here. Now, we're assuming the two things will be able to find each other from there. So the compiler would load the project, run through, get all the properties, and then look for the source code in the folder that the project exists in. So when you call compiler and give it a project name, it has to have the absolute file location of the file. Otherwise, it'll default to where the compiler lives and not where the project source code is living for its current working directory. If that makes any sense. Alright. No, cancel that. I'll just leave that there. So in our little shortcut, we go properties. I need that location actually. What's our location? There it is. Grab our properties. Put quotes. Here's our thing, and then we should have, what is it? temp.project. End quotes. Now we'll need quotes generally because you can't have any spaces in any of these file names, and which is kind of annoying, but it's just how the file system works. Otherwise, and the tool wouldn't be able to phrase the command line. It wouldn't know that this is actually a path. Right. Hit apply. Okay, save. Now that should point, when I click this, it should call the compiler and then pass the parameters to the compiler of the location of this temp file. See what we get. And it runs. This is old code, some sort of weird change that's occurred between the two things in this. These extensions are irrelevant, it doesn't matter. But because we're talking to the compiler and not the IDE, we've got to work how the compiler likes to work. So if you had a big project with many source files and you tried to do this, that's not going to work. You'd have to pre-merge all of the sources together. What I assume you're looking at doing is trying to run these things, trying to run multiple copies of the same thing in memory at once. You should be able to do that. I'll just where's the other one? There it is. There's an issue doing that, of course, because the compiler isn't located in one location. It is saving temporary data about the project that's running in that location. When you run two projects, now you're writing data, you're overriding. When I run this one here, I'm overriding this one here's startup data, which is just log files, stuff like that. Shouldn't be a big deal, but that should probably work. But if we go back to the point the point I was trying to make about, actually it's touching on this here. So if you were making an IDE, in order to get the source code from the current project to the compiler, you have to run through all of the sources in your project, and the IDE can use its own project for structure. It doesn't matter because the compilers can't load any of that stuff anyway. You've got to convert this stuff to how the compiler wants to work. So if you had a project with these three files attached to it, you'd have to run through and load these, attach them into a big string, and then dump them out as temp.source. So all the source files are in one big giant chunk. There are caveats about this too, about finding line numbers of things is actually a bit of a challenge sometimes, but that's pretty much what you would need to do. And if you ever use the include directive or any of the other directives, then there's other facets of that you've got to go through and do manually. There is actually on here somewhere, if we go back to home, I can't do a search when I'm logged out, but I think it's not, I think it's not far from here somewhere. There should be well, there is a project in here that will load PlayBASIC projects and do a load of all the source and bundle that stuff up. It's the same code that's used in PlayBASIC to DLL, because that's written in PlayBASIC. It is in here. I'm not quite sure where the stamp thing actually is. Oh, there it is. Yeah, it says it's released in 2014, so that's when I was writing PB to DLL, so stands to reason. And this does that exact thing. Is it will load, going back to this example here, it loads these files, phrases out the properties of those things, and it works out what source files are in this project, bundles them all together, goes through and checks for any include statements, then recursively inserts those includes. I don't think it uses recursion. I think it just does an insert and then keeps scanning and does a new insert when it finds another one. That's the whole process. So the code's already sitting there for people to use. It's been there for years. Look, I guess if you want to do this stuff and do, that's right, do rendering, if you use the compiler, you can't distribute that for obvious reasons, because the end user would need a licensed version of PlayBASIC to run that. A better idea is just to split the GUI elements and the render apart. Actually, you wouldn't even need to split the GUI off it, come to think of it. You'd have the whole thing as one block, and then when you're testing, just do local testing, and it wouldn't bother threading. And then when you're happy with when you've written something that works, dump an executable, maybe set a flag to run threaded. And the way it would work is the same sort of principle. As you would have your ray tracer compile out to an executable, call that with the location of the project that's going to be loading. In other words, the scene data that needs to load. So you have to serialize the scene data into something that can be reloaded back in on the other process, because these things now have no communication with each other. They don't know each other. They exist, right? So if you had the idea, build the scene definition, we'll call it, where the objects are, where the lights are, what materials things use, all that kind of stuff. And then when you call the render, you need something else too. You need, like, what fragment of the screen should this process render. If we go back to here, for example, running this guy over here, and it'll disappear now, but I'll get it back. So that one? No, it's this one. What I'm talking about is that because these are separate processes running on your machine, now you've got whatever the slice is of the process. Oh god, that's hard to explain. Windows determines how much time each process takes, right? And then it will simply switch your process off and go to the next one. So what we're trying to do, I guess, is have multiple applications running at the same time, concurrently on different cores. That means they can't share data for obvious reasons, because they end up with corruptions and race conditions between them. But what you would need to do is have it. Let's say you had even just a pair of renders. The way old GPUs do this stuff for acceleration is that you have one version. Let's say it's render 1, render 2. In render 1 here, say we draw the scene, but every even line, and render 2 would render every odd line of the scene. So that would give you much better load balancing, because what you don't want to have is, hey, this thread here renders the top half of the screen, and that one there renders the bottom half of the screen. That you're going to end up with, in a basic scene, you're going to have just a floor with a sphere sitting on the floor, and a sky that's that once rays get out of a certain point, they're stopping. So the cost of tracing this top half of the screen would be much less than the bottom half of the screen. So the whole process is going to take whatever it takes to render this bottom. If more complex stuff appears in the bottom part of the scene that requires reflections or whatever, that's computationally much more expensive than the stuff that hits the skybox, or where rays don't hit anything in the scene. So having it do, you could probably do cut the whole thing into, even if you did quarters down here, if you went like that and had a half here, I would still do interleave lines. So if I had 4 threads, I would render, this thread here would render every 4th line, this would render every 4th line displaced by 1, and the 3rd and 4th threads would render the lines that are missing between those, trying to balance out the workload between all of them. Ideally, if you could run through and do previous on the scene and build a map between some sort of spatial partition, that's actually going to be much faster than just doing brute force. I think there's a lot of scope for doing work in that way, but yeah, if you run the process multiple times, you could get it to render, and each one could dump out, let's say, just a bitmap. I mean, who cares what it is? Or maybe it's a scan line by scan line thing, dumping a file back, and then the main process, the GUI process, is sitting there waiting. Really, it's periodically checking if these apps are still running, which you can do. There's some system calls where you can do that. It's way beyond the scope of PlayBasic. You're still going to have race conditions, like a condition where the thread starts, it needed something to be passed to it, it didn't get that thing, now it's sitting there waiting forever for it to happen. All these kind of situations where it needs to be happening in a serialized fashion, but isn't doing that. Something's happening out of order and it's throwing the rest of it off. I'd put more effort into partitioning the scene and reducing the amount of workload it does in the first place, and then worry about splitting up the threads. I don't see, definitely for low resolution, you should be able to do that almost real time. And as we replace more of the math functions, or we add intersection functions, for example, for 3D, I guess it negates the point of doing it yourself. Anyway, but my point is you can have the primary thread call these other process. There's a point of diminishing returns too, by the way. If you couldn't go have 32 of these things running in the background, you're going to end up starving, like just choking the system in general. If you had 4 threads, you wouldn't cut it by a quarter. Because you realise that when these things start, they've all got to load data and get started and do things, and that's going to be interesting. You might, rather than have 1 copy of the render engine, you probably should have 4 copies of it. That would help PB start and load, and just copy all of the standard files across. Just have the your executable file with the standard DLLs, etc., all in the one folder. You'd have a tree like, if this is my project, you'd have like, I don't know, just riffing here. Let's say it's, we have a binary file for where our executables live, and then this could be, render 1, render 2 or whatever. And we just have a for loop that runs through the binary thing here, and there'd be a file in here, ray tracer or whatever. You could even just do, rather than even pass it command line stuff, you could just, when the GUI starts, you could make a copy of this folder. If you wanted 8 threads, 16 threads, whatever, we just copy thread 1 across. When that's done, if they didn't exist already, saves having to manually do that stuff. Then you work out a list of the scene and then drop in, the file in here, scene, whatever it's going to be, and in scene, I'll use the same format as before. We go, you might have I have a render thing up here. We might have like a, it's the width is the 920 by whatever, 1080, whatever, depth 32, and then like a resolution setting, where if it's 1 by 1, this thread's going to do all of every pixel on that scene. If it's maybe 2, it does every second line. Just our offset or whatever it could be. We want to start on the Y line, offset Y or something. If this is the one doing even lines, does this, or actually you could just have a step value, Y step, starting Y or something, So we're stepping every second line. We're starting from row 0 in this case to run through. Then below that, a list of scene thing or whatever, object, and you need a camera thing too, maybe multiple cameras or whatever. You can do it as a binary file, but I tend to think it's probably better doing this type of stuff as text, because it's very easy to phrase as text. You can pull this stuff into memory easily. You load the text file, split it to an array, and then just run down the rows looking for these blocks. And then inside the block here, you have a loop that goes, oh, well, find this character on the row. This is your particular setting, and that's your output there. For this kind of thing, I tend to think it's just as easy just to have a select case. Select, whatever the tag is going to be here, and select, case. Render, we have a little process loop from the current loop position to size of array. We could just loop until, have a repeat until yeah, it doesn't really matter actually. I mean, to be honest, you could just map these as each row belonging to a particular process. We run back through and process the rows against those. I mean, it's not that difficult to do this stuff, and there's plenty of examples on the forums that do exactly this. some old ones, some new ones. Well, the process is pretty straightforward. So in scene, you're looking for objects. So this inner loop is looking for an object loop here. The object might have a position in space. You know, its position equals whatever, some sort of triplet. You know, maybe it has a type classification if it's like a built-in object. This is a cube. Whatever. Position, bit of a size or something like that. 100 by 100 size is going to be a cube, isn't it? Yeah. I mean, you could just have, rather than have an object type, you can have like a cube type, and then there's a lot of repetition in that. Because objects have a lot of shared elements, like their position, size, and their colouring stuff is all going to be the same. And for things that use extra parameters, that's fine. You don't need to use them if they're not there. They'll be initialized to 0 anyway. So I don't know how I got on this shit malarkey. That's probably how I would tackle that kind of problem. I think is it call exe, something like that, run exe, something like that. It's a very basic version of that process. So we need you don't need to pass it parameters. If you use the binary idea here, where we have copies of our exe, and then we duplicate the copies, and then we just store the data that it expects to find in that location, and then when the job is done, let's say in our scene thing here, we have maybe an output, output section or something like that. Well, you don't need the sections here. You just have a whole bunch of just these kind of fields, but they're all going to run into each other at some point. You're going to have, width, duplications, and heights, and whatever. Outputs. I don't know. What would you call it? File might just be, fragment 1.bitmap or something like that. So when the program starts, it would check if this thing is actually exists, and then delete it if it does. You need to do that before the thread is started. Otherwise, the thread might see the fragment thing exists in this folder, and then try and it'll just abort. It'll just go, well, I've already rendered this part of the scene, so I don't need to do anything else. Fun and games. Going back to wherever we were. These are mostly about the IDE side of the conversation. So if you're to make your own IDE or make a bridge from an existing IDE to PlayBASIC, these are stuff that you need to do inside the IDE side. Like you get the there's a keywords inversion stuff that's stored in a temp folder when PB runs, for example, which your IDE could then load the keywords. It's just a delimited string of keywords with a section name in them. There's nothing special at any of that stuff. Yeah, the keyword list has these headings, and under each heading is a list of the keywords until there's a null line. So it's like this, whatever that was, commands or whatever it was, print, sync stuff, and then down here there might be, directives, directives, if, end if, whatever, and that the delimiting thing is this empty line. So once it finds a heading, it goes, all right, I'm in command mode, and drops these on the command list. Do we find nothing? And we go back to looking for these keyword names here. So if we find one, we pipe the data out to whatever array you're going to store these things internally, or associative array, or whatever it's going to be. This is just a selector really for where these keywords go. They don't have parameters with them that you have to pull that stuff out of, which I think this goes into down here somewhere, doesn't it? Help file has a list of the command parameters. Yeah, this thing here. Reading that is kind of weird to look at a bit, but you've got the help file location, the pipe character is the divider. So the command name, and we have divider, which are the parameters, must be the input parameters, and then the colon represents the return data, and the pipe is is the next thing, which is the location of the actual file, the HTML file in the documentation. That's how it looks up things like, so if you hover over a word and press F1, it takes you to the help. That's how that's done. So to do your own version of that, you need to phrase the data that's already there and make a version of that, do that same sort of basic thing. Lots of stuff. Alrighty, that'll do for me. It's got very short day today, so I'll see you next time. Bye.